Okay, ladies and gentlemen, we are going to do titration curves and cover all possible possibilities. I don't know, that didn't come out right. For what you're going to see Wednesday. One of these, we're titrating an acid with a base, and the other, we're titrating a base with an acid. How can we figure out which we're talking about here? If your pH starts low, what kind of a molecule do you think you start with? Acid. And at the end, you have 100% conjugate base. So HA is just a generic acid. What is the generic conjugate base? A minus. Now, in the other one, you're ending with 100% HA. You're titrating the base, right? Okay, good. We titrate acids with bases, and we titrate base with acid. Okay? Good stuff. And the most important part on both graphs is when you're half done. That is the most important part. Thanks, sir. So when we're half done, and guys, you never use this equation, but it does conceptualize a lot for us because it governs all weak acids, which these are. Don't even worry if you don't memorize it, but it isn't hard to memorize, and it's derived straight from the Ka expression for an acid. It comes straight from it. You do math to get to here, and the base is on top. Means if there's more base than acid, the pH goes up. We knew this many years ago, maybe. But we know bases raise pH and acids lower pH, I hope. And that's why base is on top to raise the pH and acids on the bottom to lower the pH numerically. The most important place on this graph is when A minus equals HA. When A minus concentration equals HA concentration, then pH is very simplified because the log of 1 is 0, and you just told me the numbers were the same, so you're doing the log of 1. So pH equals what? pKa. Both these graphs halfway. I'm going to try to do this straight line. This usually works pretty well. I'll go with the light pink. Halfway on the first one is 48 milliliters. Oh, sorry. Half of 48 is 24 is what I should have said. So the total's 48. Halfway to get there. Here's the end. Okay. Not bad. That's 48. Halfway was there. Read me the pH if you go straight across. pH equals 5 equals pKa. pH equals pKa equals 5. Okay? Now, what general functional group are you looking for? Yes, you must pick one of the two carboxylic acids. And I want to remind you, this brings the pKa lower. Like a lot, substantially lower. Less than, wow. Pen, please. No, not equals 5. Less than 5, and pKa equals 5 here. And guys, this is really close to 5, isn't it? In fact, I think if I did it a little bit with a ruler and a real piece of paper, I was a little low with my line here to start with, right? It should be there, but it's a computer. I can't get the resolution to stop. It won't stay there. I'm letting go now. Did it stay? It's below 5. But guys, that's where it's on the graph. That's where it hits the black line, right? It is 5. Okay? So I don't want you misinterpreting what I was saying and say, oh, it's less than 5. I'm going to go with answer CE. No. I would put a 4 there. There is an example, I think you and I were talking about it earlier. There is an example where it ended up being a 4, and you were supposed to pick CE when it was a 4. It's somewhere. But this one's 5, and I like it, and it's the answer. Okay? So that's the direct version of this question. Because you're starting with the acid. When you're starting with the base, you still need to think about the acid at the end, because this is true for the acid, okay? This doesn't say anything about the base. You see that? Okay. So what we have to do here is 2 parts. The first part we just did up above. Figure out what the acid is. You're going to be figuring out what this is. That's not what the question is it? The question is, what is this? But we're experts at knowing what the conjugate base looks like, right? Of an acid. We had a whole activity on it. It was the first activity in chapter 4. Draw the conjugate base of this acid and draw the conjugate acid of this base. I know I think that was our bad video day, was it? No, it was a good video day. In truth, really, are there any good video days? I'm sorry. All right, where are we going now? Yeah, we need to do the same exercise we did earlier. Where's halfway? And we get our marker for there and there. And half of 12 is 6. I almost said the same thing before. Yeah, and then straight across. That's not even close. Now it's above the graph. Okay. I can't move it, so it has to be where it belongs. Oh, I can. Sorry, I take it back. Do you agree that's right on the 10? And I didn't make a mistake here. That was just a little too tall. There you go. So acid pKa is 10. Right? I got that from here. So what's your only acid with a pKa of 10? Ammonium, somebody said. I like that. Ion, I like that, because yeah, they go together. So some kind of nitrogen with an H, 3 bonds and a plus charge, right? So now the question is, draw me the conjugate base, please, because it's the answer. Amine, right? You lose the H plus, right? Anytime you have to draw a conjugate base, you lose H plus. Bless you. We'll go with purple. Lose that H. If you want to be picky, I mean, it's not a big deal. There's a lone pair, but you don't need the lone pair. Not for this question. So which of the answers matches that most closely? A, B is actually correct, sir. Highlight it. And, you know, I like to give away as much as I can today. There's another amine below it. Do you agree? Yeah. That would be the pKa equals 9 amine. No, sorry. Do you realize this was the acid that became that base? And that's a pKa less than 10. That's a pKa equals 10. That's the one that we love in this question. But if this ended up being a 9 instead of a 10, your answer is the one ABC now. Okay? So once that was a hypothetical. If that number was not 10 and it was 9, then that was the acid, and that means this was its conjugate base that is the answer to the question. I'm just trying to give you, I'm just trying to get the point across. I can make any of those answers the correct answer unless you're titrating an acid and it's this, that doesn't have a proton. That's a base only, right? But, you know, if I use the right graph, I can make any answer right. There, that's the end of the story. And, yes, sir. Now, the bromide is a strange example of another form of spectator. He was worried about what's the bromide doing. And I'm glad he brought it up because we haven't brought this up before. It's to balance the charge of the cation. Bromide's just going to float around in solution. And he's like a who's cares from the beginning. Remember we crossed off Cl minus when we made it from HCl? It has no bearing on an acid-base reaction. Well, this bromide that was there from the beginning never had any bearing in the beginning. It's floating around in the water. It's a spectator, you can cross it off. Mostly we're used to crossing off anion, a cation, but the cation's the acid here. Don't cross it off, please. Okay. It does, it's just there to balance the ammonium's plus charge. That's an ammonium there beside it. Ammonium is a nitrogen with a plus charge. Change what you learned in 141 and expand it. 141, you learned ammonium was NH4 plus, correct? Any of those H's can be replaced with carbons, and it is still called an ammonium. Okay? Ammonium is broader than they taught you, but they didn't teach you because you didn't need to know that yet. Okay? And an ammonium pKa is what number again? Ammonium 10. Do not confuse that in any way with the pKa of an amine, which is nowhere near 10. An amine is normally, it wants to be a base, and now you're asking it to be an acid. It does not want to be an acid. It is a reluctant acid. Reluctant means very high pKa. What is the pKa of an amine? 40. Good. So that should help you keep those two straight. When do I use 10? When do I use 40? Well, if it's got a plus charge, you're using the 10. If it's an amine, which is neutral, you're using the 40. Okay? All right. And we're stopping. And we're ending.